Hello there everyone. In this video I'll be showing you how to create piecewise functions that include a whole discontinuity, otherwise known as a removable discontinuity. Now for this to happen in a piecewise function, you have to have lines that actually meet at the same point, but it has to be a point that is not a part of the domain, an open point. Now the simplest way to do this is to use the same point for both lines when writing the equations in point slope form. Notice here I'm using 1, 4 for both of these, here for the x1 and y1 in both equations. And make sure that the domain restriction does not include the point where these two lines meet. Make sure that you're using strictly less than symbols instead of less than or equals. And then to create an open point, you're going to also need to include that coordinate at that juncture between them. So let's go ahead and take a look at a few examples of doing this. In our first example, we're going to create two lines where we have a hole in our piecewise function at the coordinate 2 and 1, which we can already see here. All we really need to do is just create two lines that are going to meet at the same point. Now I can really choose any slope I want, any inequality I want for the domain restrictions. So I'm just going to be kind of creative here. Let's go with y is less than or equal to, let's go negative 2/3 x. Oops. And here's where I have to be careful and make sure I'm using this coordinate 2 and 1. So that's going to be x minus 2. And then plus 1. Now I have to make sure it stops at this point. I'll start it at negative 5 less than or equal to x is less than 2, because I want to make sure that this is an open, undefined point on this line. Alright, now I'm going to go and do the other side of this. This time I'll go with y is less than or equal to, let's go with a positive slope this time. Let's go with 5/3 times, again I want to use the exact same coordinates here, so I'm going to do the same thing, x minus 2 then plus 1. This time I want to start it at our open point here, so I'm going to begin the inequality with 2 less than x, and let's say less than 5 as well. If we check both of our lines here, both of our inequalities, you'll see that both of them have that undefined point where the two lines meet. So we have created a piecewise function that has a removable or a whole discontinuity. In our second example, this time we have to create a piecewise function that has two holes. One at negative 3 and negative 2, and the other one at 2, 4. So in this case, we're actually going to have to create 3 different lines, so that way it connects these points together. So for the first one, I'll start with connecting my first line to this point, negative 3, negative 2. So I'll go with y is less than or equal to 1 times x plus 3 then minus 2. That way I make sure it goes to that point. And this one will go from negative 6, less than or equal to x, less than negative 3. Again, making sure I use strictly less than to preserve the undefined nature of this point here that we want to have be a whole. Now the next thing I need to do is connect these two points together. So we've done this before. We need to use point slope form, find the slope between these 2 points in order to graph it. So y is going to be less than or equal to, the slope here is going to be a positive one. The rise is going to be from negative 2 to 4, so that's a rise of 6. So I know it's going to be 6 over the change in the x values from negative 3 to 2 is 5. So it's 6 over 5. And then I need to use one of those 2 points. So I can either use negative 3, negative 2, or 2 and 4. I'll use 2, 4 this time. So minus 2 on the inside, then plus 4. Oops. And we got to restrict the domain between both of these. So this one will go from negative 3 less than x less than 2. Again, making sure we're using strictly less than for both of these endpoints. Then we need to make sure that this continues on. It has to have two holes, not just one hole and an empty endpoint. So I need to create one more line. This time I'll keep it pretty simple. I'll make a horizontal one this time. This time, if I make it horizontal, it'll have to be at the y value of 4. So I'll go with y is less than or equal to 4. And this one I will have go from 2 less than x. And you know what? I'll make this one infinitely long. Why not? So now I've made a piecewise linear function with holes at -3, -2, and 2, 4. For my third example, I simply have to write a linear piecewise function that has this domain from -infinity to -1, excluding -1, and then again from -1 to infinity. So this means that I have to have an infinite domain except for one point here at -1. So just to know exactly where I'm going to have the hole, I'm going to type in x equals -1. This way I can just choose a point here. That'll be where my hole is. I'll go ahead and pick something like -1 and 3. Okay, we can change that right away to an open point here. That way I know it's going to be the hole that we're looking for. Now, I'll go ahead and get rid of this line since we don't need it anymore. And just like we did in example 1, all we need to do is to create these two lines that meet up at this point. So I'll do that really quickly here. Let's say y is less than or equal to -3 halves x. Again, I wanted to go through this point, so plus 1, then on the outside plus 3. And I have to be careful here because in this situation, I want this inequality to go all the way to the left to -infinity, but stop here once it gets to -1. To do this, I can simply just say I want it to be wherever x is less than 1, just a -1, just a one-sided inequality instead of a two-sided, and we can make sure, yes, it's undefined here at this point. So I'll go ahead and make one more of these. This time, I kind of like last time, I'll keep it simple. We'll make a horizontal line. Y is less than or equal to 3, since that's the y value of our point. This time, we're going to need to use, again, another one-sided inequality, but this time I want to go to the right. So instead of using less than, I'm going to use, for the first time, greater than. Again, -1. So here we go. Now we have an infinitely long inequality here, this piecewise function. It covers an infinite amount of space. There's only one point that's not included here, and that's -1. For either part of the graph. So there we go. Now you can work in some removable discontinuities into your graphs.